Here we are learning about calculating limiting reactant, theoretical yield, and percentage yield. Here is the problem. In the reaction shown below, 12.0 grams of nitrogen are reacted with 4.0 grams of hydrogen to give an actual yield of 13.2 grams of ammonia. And you have to determine the limiting reactant, the theoretical yield, and the percentage yield. The good thing, you are already given a balanced equation, so no worries about writing the balanced equation. So let's start with the first part. We're going to first determine, so first part is the limiting reactant, and also they're talking about the theoretical yield. So let's start out figuring out which of these two substances will be the limiting reactant. So here the substance, whichever is going to produce the least amount of the product, will be the limiting reactant. That's how you figure out the limiting reactants here. So let's start here. When you're given 12.0 grams of nitrogen, first you're going to convert this into its moles. So when you're doing this conversion from the given mass to the mass of another substance, that mass is unknown to you. So you're going from known to unknown. You use three fractions, and those three fractions will be used using three equivalents from here. Guys, you don't have to always write these equivalents for me, but you should know them. The reason I always write them, that way you know where am I getting the conversion factors from, because I don't want you guys to memorize anything. All right, just it's all about understanding. Let's convert this mass of nitrogen to its moles, and here is the relation. 1 mole of nitrogen has molar mass of 28.02. So we are multiplying this by the molar mass. Molar mass is the conversion factor we are using here. Okay. You cancel the units, the same units. So what you did, in order to convert the mass of one substance to its moles, you multiply by molar mass conversion factor. This is the molar mass, even though it's inverse. Okay, so here the next part is you're going to convert the moles of this one substance to the moles of another substance. So here we are talking about nitrogen and ammonia. So our another substance is ammonia. So let's compare the moles from the balanced equation. For 1 moles of nitrogen used, here is the 1. When you don't see any coefficient, 2 moles of ammonia are produced. So in the problem, we are converting the moles of nitrogen to the moles of ammonia. So this needs to come at the top. So that's how we are going to write fraction from here. 1 mole of nitrogen consumed produces 2 moles of ammonia. Cancel these. Now we don't stop here. We have to keep moving on. Now we are going to convert the moles of ammonia to its mass. Again, multiply by the molar mass conversion factor. So here it is. For 1 mole of ammonia, how much is the molar mass? 17.04. And we are using the periodic table to get the mass of element and to determine the molar mass of compounds. So here we are going to get rid of moles of ammonia. We don't want the moles, we want the mass. So this goes at the top. Okay guys, when you do the math, you solve it, you are going to get 14.59 grams of ammonia. Well, here 1, 2, 3, 3 significant figures, so you're going to round off here. You get 14.6 grams of ammonia. So 14.6 grams of ammonia are produced using 12.0 grams of nitrogen. Now we also, in order to find the limiting reactant, we also have to repeat these same steps, that how many grams of ammonia will be produced using 4.0 grams of hydrogen. So repeat the same steps. You go from mass to moles to moles to mass. Okay, so we are given 4.0 grams of hydrogen here. Using these many grams, how many grams of ammonia can you produce? Same steps. Now we convert this mass into moles. I'm using this equivalent fraction. 1 mole, the mass of 1 mole of hydrogen is 2.02 grams. So 2.02 grams are present in 1 mole of hydrogen. Cancel, cancel. Now convert this into the moles of another substance. Here is we are comparing the moles of hydrogen and ammonia. For 2 moles of ammonia produced, we use 3 moles of hydrogen. So 3 moles of hydrogen are used to produce 2 moles of ammonia. So I'm making all my fractions from these equivalents. Okay, you always keep the unknown, the unit that you want at the top, and the starting unit at the bottom. Now we don't stop here. We have to convert this moles into the mass. So you use this from here, make a fraction. 1 mole, the mass of 1 mole of ammonia is 17.04. So 1 mole of ammonia has the molar mass 17.04 grams. Cancel moles and moles. Now you solve it. When you do the math, you're going to get 22.49 grams of ammonia. Well, then 1 and 2, two significant figures. So I'm going to round off here. You get 22 grams of ammonia. You must write the unit and the substance, guys. So now, which one is our limiting reactant? Is this the nitrogen or the hydrogen, which is going to limit our reaction, which is going to control the amount of product? So what happens is the reactant that gives the smaller calculated value of the product is the limiting reactant. So here you have 14.6 and you have 22 grams. Now which one is smaller here? This one is smaller. This is less. So our limiting reactant will be will be nitrogen. Okay, and so our hydrogen is excess reactant. Okay guys, now the next part is, what is the theoretical yield? That's the last part asked in the problem. So we have to figure out, we're going to use this formula here. Theoretical yield is so first, and then one more thing we forgot to tell like which one is the theoretical yield. Let me go back to the problem. So we have to find limiting reactant. We did figure that out. Theoretical yield, yeah. So the theoretical yield is the smaller quantity. So since this is the smaller quantity, this is bigger, this is more, so our theoretical yield is 14.6. So we answered, what did we answer? We answered which one is our limiting reactant. That was the question, A. And then we were asked what is the theoretical yield, which is 14.6 grams of ammonia. So limiting reactant nitrogen, theoretical yield 14.6 grams of ammonia. And C, now we are working on C, where they ask you to find the percentage yield. Here is the formula for the percentage yield. This is the ratio of actual yield of a reaction to the theoretical yield. And don't forget to do times 100%. So this is actual yield is actually the mass you really or actually cover, make in the real world when you carry out reaction in the lab. And this one, the theoretical yield, is the mass that you should have made if it was a perfect chemical world. Or in short, you could say that what you did get, okay, over what you should get. So should get is your theoretical yield and actual yield is, that's what you get. Right? Now let's plug in the values. Actual yield, we go to the problem, is given here. It says 13.2 grams of ammonia. So instead of actual yield, I'm writing 13.2 grams. And here theoretical yield, we just figured out the theoretical yield is 14.6 grams. Writing from there. And solve it. You get 90.4%. Okay guys, so in this problem the actual yield was given to you. You determined the theoretical yield and at the end you figured out the percentage yield. Let's do one more problem where you have to figure out the actual yield. So here the problem says, determine the actual yield of calcium carbonate when 37.6 grams are theoretically possible and the percentage yield is 75%. So what is given to you? This is the theoretical yield. This is given, okay? And this is the percentage yield, which is given. So percentage yield is given, theoretical yield is given, and what you need to find is actual yield. Actual yield is the one that I'm putting the question mark. So there are two ways to solve this problem. Since you have to find actual yield, what you can do is Let's plug in the values first. So percent yield is given 75%. I'm writing 75% here, actual yield, and theoretical yield is 37.6. So I'm writing here 37.6. Okay. All right. So you want to simplify this, and at the end, all you want is actual yield. You don't want anything else, right? So you want to solve this. In order to solve that, what you can do is you can divide both sides. Let me write this for you. Divide both sides. You're simplifying by 100%. So when you do that, let me write here for you. Both sides by 100%. Cancel. This percent sign cancels. You divide this, you get 0.75. Actually yield over 37.6. Okay, now we can simplify it further by multiplying both sides by 37.6. So here 37.6, actual yield 37.6 times 37.6, 37.6. Cancel. Now you multiply this, you're going to get 28.2. So that is actually your actual yield. Or you can say actual yield is 28.2. Don't forget the unit and the substance. This is what you figured out. Actual yield of calcium carbonate is 28.2 grams when you have the theoretical yield of 37.6 and the percentage yield is 75%. The other way you can solve it is called transpose method. So transpose is actually mainly, it's like a transfer. So what you do, you just transfer the terms. So what am I going to do? What do I have to find? I have to find actual yield. Okay, so if I leave this actual yield on this side and I take my theoretical yield to that side, this side it's on division, I take it to the that side, it will be in multiplication. 100% on this right side is multiplication. When you take to the left, it will be division. So let me write this down for you. Okay, so here it was in multiplication, you moved it to other side, now it's in division. Theoretical yield, it was in division, you move it to other side, now it's in multiplication. That's what actually happens when you use the transpose or transposing method. You're just transposing terms, just transferring the terms. And here the percentage yield, what is it? 75%. Theoretical yield is 37.6. And you're figuring out the actual yield. Cancel the percent and percent. You will have 0.75 times 37.6. Let me write it for you. Times 37.6. Okay, solve it. You get 28.2. Again, don't forget the units. This is your actual yield. Or you are going to say actual yield is equals to 28.2 grams. You always write what you have to find here on the left side. That's why I'm writing like this. That's why I moved it this side too. I wrote it like that. So you saw the answers are actually same. There are no differences in the answers. 28.2. So you can use whichever method you're convenient with. I personally like the transposing method. Here are my quick notes from this video, guys. Please make sure that you take time and read them sincerely. Add on to your notes if you missed anything in class. And here are the notes from my another video on limiting reactants. Okay. Alright, hope the video was helpful. Thank you for watching, guys.